Guten Morgen. It's really great to be here. I'm so happy to see that open source is here to stay in energy and to grow. So today, we already had some great panel to start off, talking about open source for utilities, and just heard a great example of Everest, building open source community and business around it. And today, Tony and I will talk about our journey of one of our open source projects at Alliander, where we took an ID to an Innersource project to an open source project. But first, before we get started, let me introduce ourselves quickly. So I'm Jonas from the Bogaard. I work at Alliander's open source program office. And for those who are not yet familiar with Alliander, we are one of the distribution system operators in the Netherlands, which means that we provide reliable, affordable, and accessible energy distribution in a large part of the Netherlands. And I'm here today, joined with my colleague, Tony.
Yes, hello everyone. My name is Tony. I'm principal scientist at Alliander System Operations, mainly focusing on grid simulation and grid calculation in distribution grid. I'm also a part-time assistant professor at Eindhoven University of Technology.
And today we will use the power grid model as our case study. Show me some hands for who already is familiar with the power grid model. I hope a lot of them. It's good to see already a lot of hands. For those who don't raise his hand, the power grid model is a project that helps to better simulate and analyze the behavior of the electricity distribution grid. And this helps us to understand the grid dynamics, plan the future grid design, and also support decision-making in the rapid changing energy system. And we see at our organization and more other organizations that power grid model find application in various areas. This can be grid planning, this can be grid expansion, but it can also be grid congestion management studies. But enough about the power grid model itself. That's not what this talk about is. It's more about the journey that started with an idea, where we started with a simple question: can we analyze the grid in a smarter and automated way? The next phase, the research phase, where we tested this idea in a research project and also brought it to the first pilot phase to see if it could actually work. And the Innersource phase, where we shared the model inside the company so that more teams could adopt it and build on top of it. And the last phase is the open source phase, where we've also made the project publicly available so others could benefit and contribute. So let's get started with the ID phase. Tony, could you share a little bit more how this ID for the power grid model come around?
Of course. So what you see the power grid model today is actually a result of almost 8 years of continuous improvement and ideology and development. So if we go back in time, let's say 10 years ago, when you were an electrical power engineer graduated just from the university and you got a job at a distribution system operator as a power grid analyst, what you're going to do? Your daily job will be something like this. So you will load some data files in your computer, in laptop, or sometimes in the server. You load the files in the commercial software. This is just made up, by the way. This is not the real software. And then you run some interesting calculations, usually power flow calculation, short circuit, this kind of harmonic analysis, and this kind of stuff. And then you get some results. You're doing this day after day, with different scenarios, with different customer requests, or maybe new grid expansion and so forth. But the key is that you usually are a power engineer who are doing this kind of stuff manually by the software, maybe with some built-in automatic tools to calculate some time series calculations like I show here with some results. But this has to change. So we are now in an energy transition that there are so many statistical plays here, like when do you charge your electrical car? When do you have your PV panels? When the sun is actually shining? When we are looking at the future of system operations, for both real-time operation and the long-term planning, you are going to calculate a lot of calculations, not one, not 100, not even thousands, sometimes millions, if not billions of calculations. And so how do we do it now? You need your grid data in the database, and you need some automatic software programming, a scripting software to actually load the data, to instantiate a model, and then you do some calculate. All this is being done using scripting. So no mouse, no keyboard, no click a button of powerful calculation. And then you deploy your software into the cloud. Afterwards, of course, you publish the results back to the database. Another thing interesting is that you don't see any GUI here. Of course, you need to visualize the results somewhere, but that's not out of the loop. There will be a separate visualization layer built by separate teams to actually load the results and the grid topology from the database, and then visualize them in a web GUI or in a desktop application or not. But now the problem is, what is a good model? So I have a capital model there. What is a good model to be suitable for this scenario? That was the problem when we were 8 years ago, 10 years ago, we were facing. So how can we get a model which should be suitable for this scenario? So we have an objective. So what do we need? We need a high-performance software library. So we don't need a very comprehensive commercial software with a nice GUI with the buttons you want to click. No, we need a pure calculation engine which should be optimized for performance. We're really talking about millions of calculations here. So performance is important, a well-defined API. So it has to be rigid in the sense that we have a API defining software stable so they don't break between the versions. Well documented, so that's well defined. And also designed for scalability. So you're not going to run the software in the laptop. Of course, you will debug the software in the laptop, but the real production data will be run in the cloud with hundreds of CPUs and GPUs. And that time, the problem is we couldn't find a viable commercial or even open source solutions at the time. So we're looking at the time frame of 2015, 2016. At that time frame, for both in that time period, both the commercial and the open source software, they were focusing on providing an all-inclusive solution. So the installable, executable that you can install it to actually run the calculation, use the nice GUI with the buttons. You could have some scripting possibility, but that's very limited, and you're very bound to the scalability issue when you want to deploy it. So what do? We have eventually developed an in-house prototype to say, hey, we know the mathematics, we know the physics, we have the good electrical engineer graduated from university. Why not just build a calculation engine ourselves? And to see how that will go for 1 or 2 applications inside our company. At the time, we were doing like long-term planning using this kind of scenario calculations. And that turns out to be pretty good. We achieved a factor of like 10 to 100 speed boost just by implementing a stuff which is bare minimum but can be used in our applications. Yeah. So what do we do next?
So the next step, I think it's great that Tony mentioned that, where the idea came from and the research project where we saw, hey, this works on 1 or 2 use cases. But the next step was scaling it internally. And there we adopted the Innersource approach, essentially applying open source principles within the company. So Tony, can you share a little bit more about how Innersource has been implemented in the PowerGrid model project and how it worked in practice and how it benefit Alliander in terms of collaboration and development?
Yes, so at some point our prototype began to break because, you know, that's a prototype. It is only fine-tuned for very special application. So at that time we were thinking, do we allow this continuing or do we do something from scratch? And the decision was quite clear. We developed something from scratch. At that time, we were really thinking about software engineering principles. So all the open source software engineering principles, review, pull request, version control, documentation, everything, we have to do it as if the software was already open source. That's the mindset. Another important mindset is that we had a completely separation of the corporate internals and this piece of calculation engine. So we know when the time comes, when we actually hit the button to become open source, there's no extra work to say, hey, we have a database connection hard-coded somewhere in the code. No, we don't have that. The code is completely separate from the corporate internals. And this actually very unexpected result. Even during the Innersource period, we got a lot of attention by our internal projects. They are very easy to switch to the new Innersource project. Like we have something called automatic network design, so they run simulations with different combinations of new assets, congestion management, monitoring, grid planning. They all were using this piece of calculation engine. And at some time we say, okay, now the times have come. Maybe we want to actually hit the button to become open source.
Yeah, so building on that success of Innersource, as already Tony mentioned, the next strategical step was to transition the project in open source. And I think it's good also, this morning there was already talked about motivations to invest in open source, but there were 4 key motivations for us to step in open source. So one of the motivations for us was cost efficiency and scalability. Open source helps to cut future development and running costs, because you can share the tools and ideas across teams and organizations. Also, collaboration and ecosystem growth. Open source makes it easier to build things together. And also share knowledge. I think the summit today is a great experience of that, how people come together, share ideas for new features or ways to extend the project in new use cases. And also open source, thirdly, open source really can also help in strategically positioning your technology in the sector. By sharing tools openly, open source can help to set the standard for your tool in the market. And fourth, and I think that's also a very important one, especially for industries like us, is talent attraction and retention. Engineers and also researchers love to work with open source. And really also attracts the talent to work at our organization in these projects. But before going open source, we sure want to make a few things, make sure to cover a few things. Because it's a big thing, bringing your project and code from internally to the public. You want to make sure that things are covered. And it really helps, I think already Lucian mentioned this in the panel this morning, that we at Alliander have an open source program office, which is our internal knowledge center on open source, which supports this process of bringing projects open source, but also have the expertise from previous projects on how to do so. And one of the things the OSPO offers is this launch checklist. And this covers, for example, the business case aspect. It's important if you bring something open source is to have a plan. What are actually the goals you want to achieve when you bring it open source? Who is your intended audience for this open source project? And what's the added value for this audience for this open source project? How likely is it that they're going to use it? Are they going to contribute it? And what investment is also needed to bring it open source? And secondly, the legal aspect, there was also some questions about that in the panel, is important. You want to make sure that's covered. Yeah? And you have also to think about under which license you want to bring the project to open source. And if there's any trademark decisions you might have to consider. And then the next step is the technical setup. Are all sensitive information like privacy or security information being removed? Is the basic documentation right? And is also the code clean and easy to understand? And also importantly, is there any automated testing that makes contribution more easy? And fourth, when you have the technical setup done, it's also important to think about governance and have a clear governance. So think about how is your open source project governance? And do you want to bring your project also under open governance, like a foundation like Linux Foundation Energy? And also, helps this governance to make clear decisions and validate new contributions. And fifth, which is also important, is creating awareness. Have a plan to spread the word. And how will you do that? How will you make sure that everyone, if you put it on GitHub, it's most not likely to be found easily. So you have to create awareness, invest in that, and make a plan for that. And also who's going to lead that from a community advocate role. And Tony, I often say that making the project is open source is the easy step. The hard step is, and the real challenge is to making a thriving community around it. So can you share a little bit how we did that for the Power Grid model?
Yes, I think we have a strategy to see with the ambition to become part of LF Energy, but first started as our own hosted open source project at the beginning. So Power Grid model in its first year was open source under Alliander organization, of course with a very close connection to LF Energy at the time. And we were officially admitted to the LF Energy after 1 year of open sourcing in 2023, when we were actually presenting also the model in Paris at the time. Of course, after joining LF Energy, we have a lot of community management, and one thing we have done so far is to have regularly meetups with the communities, with contributors, with users, stakeholders together. And previously, we have done this once per half year, so that was pretty frequent. We gather the people together, and then we present the use case. We discuss, brainstorm about the new features, new roadmap, and so forth. But after some time, we see the community grew, and then to gather people once per half year would be too much. So we changed it to a schedule of once per year with even more big event. And the last time was in TU Delft. Thanks TU Delft for the organization of this event. But it's a very good engagement with the community. And another thing which is important is to stimulate multiple levels of contributions. So you don't have to commit code to become a contributor for PGM project, actually for any open source project. If you submit issues, report a bug, or request a new feature, or even just look at the documentation and give some asking questions like, I see this description of this function doesn't make sense, can you improve it? That's already huge contribution to the project. And of course, for Power Grid model, it's a physical modeling. So many people actually contribute by submitting new proposals on physical modeling and calculation methods, which is also quite a valuable contribution. Another thing is, of course, a stable release. So we cannot break things so easily. There are so many people depending on us, and we have to make sure that the things are stable as possible.
So looking back, bringing this project from an idea to an Innersource project to an open source project, we learned a few key things which we would like to share for you, which also might help you in your journey to start an open source project. So in regards to technical lessons, it helps if your project is modular and scalable. We designed, as Tony mentioned, the Power Grid model to be modular so that parts could grow independently, and also made it easier to add new contributions and adapt it for different needs. And secondly, good documentation matters. It helps teams to understand the project, how to use it, how to contribute it, how to extend it. And also in terms of organizational lessons, clear and open governance is key. And solid and transparent framework helps us to manage decisions and also manage contributions smoothly. And secondly, I already mentioned it, having an OSPO in our organization also made a big difference. It gave us a central place for projects like Power Grid model, but also other projects for questions about open source strategy, support, but also internal decisions. And thirdly, open source is also very much a culture thing. As already mentioned in the panel, trust is everything. Open source and open source collaboration can only work when people really feel safe to share and challenge ideas. So stimulating that culture in your project is essential. And also having transparency and teamwork built in the project is key. It helped us to break down silos within the company, but also across organizational borders and spark innovation. And third, I didn't mention on the slide, but also be brave. Starting an open source project, especially if it's your first, can be scary. And don't be afraid to make mistakes. They help you to learn and grow, and also learn from the people who are sitting next to you, or you meet at a coffee in a few minutes. So I hope sharing this journey inspired you also in your open source project. And my call to action today will be, let's stop reinventing the wheel over and over again, and let's see if we can build more together. So thank you very much, and looking forward to speak to you later.